This is the second part of our video on section 10.2. We're going to find exterior angles in this video. So obviously your interior angles are inside the shape. The exterior angles are not inside the shape. But there's another part to the definition that's important. Interior angles and exterior angles must add up to 180. So notice how, I'll use a highlighter here for you. Notice how this purple angle and this yellow angle make a straight angle. Interior angles and exterior angles must add to 180. So your exterior angle is outside of the shape and it combines with that interior angle to make a linear pair. Okay, so I'm going to quickly write in my exterior angle measures. So if I know the interior angle, I'm going to know the exterior angle. And again, the math, I'm just doing 180 minus 55 to get this angle. Okay, so we're going to focus on one exterior angle at each vertex. What would the exterior angle sum be? So I'm going to add 115, 120, and 125. If you add those together, you end up with 360 degrees. So in a triangle, the interior angles add up to 180, but the exterior angles add up to 360. We're going to do the same thing for this next shape. This next shape is a quadrilateral, and it's got 4 right angles. That's a rectangle. And we'll talk about that more as we move through this section. So see if you remember that definition. If your interior angles are each 90, then your exterior angle is going to be 180 minus that 90, which is 90 also. So your interior and exterior angles are not the same unless they're 90. Okay, supplementary is what we're looking for here. What would the exterior angle sum be in a quadrilateral? You got 4 90-degree angles. Notice how it's also 360. So your interior angle sum for a quadrilateral is 360, and your exterior angle sum for a quadrilateral is 360. Okay, let's do one more example. I'm going to find all of the exterior angles first. Then I'm going to add those together. It might take me a while to write this, but you should be typing this into your calculator. You're adding up these 6 numbers. Okay, and if you might have guessed it already, the exterior angle sum is 360. It doesn't matter what shape you're looking at. The interior angle sum is going to be different as your number of sides increase or decrease, but the exterior angle sum is always the same. It's always going to be 360. So that's our next theorem. It's the polygon exterior angle sum theorem. In any convex polygon, the sum of the measures of the exterior angles, one at each vertex, is 360. So you don't need to do any math. You don't need to do any calculating. What is the exterior angle sum for all octagons? 360. What's the exterior angle sum for all quadrilaterals? 360. Exterior angle sum for all hexagons? 360. Exterior angle sum for all decagons? 360. Hopefully you see a pattern. Here's a tough one. Exterior angle sum for all 102 gons. Yeah, it's 360. Okay, so that's really valuable. Name this shape. It's got 5 sides, 5 vertices. This is a pentagon. Is this a regular pentagon? Well, Based off of appearance, yeah, it kind of looks like it. I meant for it to be. So take a second, let's put those arcs in those spots. And then let's put those slashes there as well. I meant for this to be a regular looking pentagon. What does that mean about the interior angles? They're congruent. What does that mean about all of the exterior angles? They're also congruent to each other. What is the exterior angle sum? 360. What would the measure of each exterior angle be then? Well, if you know all 5 of them are the same and they add up to 360, what is 360 divided by 5? If this is a regular shape, every exterior angle is going to be 72 degrees. Now here's where this saves you some time. You can also calculate the interior angle measures, and you don't need that formula we used in the last video. Interior angles and exterior angles are supplementary. So each of those angles has to be 108.